Thank you everyone for joining our webinar between Banksia Scientific and representatives of TIP Biosystems. Speaking today, we've got Dr. Dieter Trau, who is the Chief Technical Officer and founder of TIP Biosystems and the main inventor of their technology, the Photopette ultrafast handheld spectrophotometer. Dr. Trau is going to take us through the technology and its applications and explain to you how you can really benefit in your workflow from using a Photopette in your lab. Now, Dr. Trau, I'll hand over to you so you can talk to us about the TIP Biosystems Photopette.
Okay, thank you, John. So welcome to our today's webinar by TIP Biosystems and Banksia Scientific Company. So today I want to introduce a Photopette spectrophotometer system, its application, and we can also have a question and answer session. So what is a Photopette? The Photopette is a new concept of a handheld spectrophotometer, and it has a revolutionary new workflow. On this slide, you can see the Photopette system. It's a system which is composed of a device on top and a cuvette tip that is replacing the traditional cuvette, which you see here on the left, and our software app, which is available in Android and iOS. So these three components, they form a seamless system. So how does the Photopette works? The Photopette here seen on the left is a truly handheld device. It has light sources, which are LEDs, and it has a photo detector, and it's a fiber optic based device. What you also see on the left here is the fiber optics at the end of the Photopette stainless steel stem, and you see the cuvette tip. And in the middle of this picture, you see a bigger view of the cuvette tip attached to the stem of the Photopette device. And how does this work? Light is generated by the LED. It's guided through the fiber optics and is then transmitted through the liquid, which has entered the cavity of this tip. So the liquid is here. And the light is then absorbed in the liquid and is reflected on a mirror, which is part of the cuvette tip, and is then reflected back, collected by another light guide, and directed to the detector of the device. So here you see now the inserted cuvette tip into the liquid, and the liquid has entered the cavity. The Photopette is a change in the usual workflow that we see in the lab. In the usual workflow, we usually have a sample collection at the sampling site, we have a sample transport, we have a sample preparation, and we have benchtop instruments, usually connected to a PC to analyze a sample. In the traditional way, the sample is transferred into a cuvette, either made from polymer or made from glass, and the cuvette is then inserted into the spectrophotometer. The photometer is closed and the measurement is performed. So this workflow is completely changed with the Photopette device. For the Photopette device, the device comes to the sample and not the sample comes to the device. Here in the lower part of the slide, you see some examples using the Photopette system inside a cell culture hood and measuring directly into the container with the sample. Here the same, this is a hood for work with DNA and RNA. And in the next picture, it's a setting in a brewery where the yeast cell density is directly measured here in this sample container. And on the right, we see a scenario for environmental testing, where turbidity or other measurements are directly taken in a river stream or in some other sample. So the Photopette is a family of products. Here you see the product family. It's called Photopette Bio, Photopette Cell, OD600 Turbidity, and our custom models. Most of our devices have 3 fixed wavelengths, like the Bio and the Cell. Some devices, like the OD600, only has 1 wavelength. And the turbidity has 2 wavelengths which relate to the ISO and the US norm. So the key features of the device, it ranges from the UV to the visible spectrum, from anything like 260 to 1000 nanometer. Basically, the company can build any custom device with 3 wavelengths in between this range. So the light sources are LEDs. There is no sample transfer or cross-contamination. The device has a very large absorbance range, up to OD of 3, with an accuracy or reading of 0.03. The measurements are very fast. It just takes 2 seconds. The instrument has the ambient light compensation, so there's no need to shield from the ambient light. It's powered by a lithium-ion battery, which can make about 20,000 measurements per charge. The app is available in iOS and Android. Together with your measurement value, the date, the time, and the GPS position are saved, and the user can also add a picture or can add a note. All this data can be exported as CSV files to email or the cloud. We have designed the Photopette in a way that is compatible with most sample containers that you find in the lab. Here on the left, you see direct measurements of mammalian cell density in what's called a T75 cell culture flask. In the center here, you see a measurement in a typical centrifugation tube of 25 or 50 milliliter, and on the right, measurements in an Erlenmeyer flask. The instrument can also be used in reaction tubes of 500 microliter to 2 milliliter, and can also be used to measure 96 well plates. There are a number of applications in different industries. Here on this list, you see industries like the life sciences, environment, food, beverage, and some industrial applications. All those information is also available on the TIP Biosystems webpage. And for most of these applications, we provide application notes. Let me give you some examples of the performance of the device and some applications. On this slide here, you see a direct DNA measurement. So there's no reagent or anything required. DNA concentration can be directly measured in the sample container. This is a typical life science applications, and typically we have sample containers here like microliter tubes of, for example, 500 microliter. And you see here a calibration curve for DNA with a very good linearity. And on the right, you see a benchmark against another microvolume spectrophotometer, which is in blue, against the Photopette. And the correlations that we see are all very good. Another application here, also for the life science sector, is the direct protein measurement as 280 nanometer. And again here, this is calibrated against BSA, bovine serum albumin, protein, and you see a very high linearity, and again also benchmarked against a standard, a benchtop instrument, which is also a microvolume spectrophotometer in blue with very high correlation. Other direct measurement applications are, for example, cell densities. So in the tissue culture lab, the typical application is to measure mammalian cell density in your cell culture flask, such the flask I showed before here, like the T75 flask. So inbuilt in the Photopette device from our family called Photopette Cell, we have different calibration curves for different mammalian cell lines. And you can see here a very good linear correlation. And then as a very high absorbance above 3, we see a plateauing of the curve, which is the normal behavior that you find always. And also here, we have benchmarked this, or we have calibrated this against a hemocytometer measurement for the determination of cell numbers. But you may know that hemocytometer measurements are very tedious. They require manual counting under the microscope and take a very long time. So this work is now replaced by the direct measurement of the cell density in your culture, which can be done within seconds. Another example, which is also accessible through the Photopette Cell device, are enzymatic measurement or enzymatic kinetics at the wavelengths of 340. 340 nanometer is used for the NADH, NAD, redox system, which applies to many enzymes like the ethanol dehydrogenase or lactate dehydrogenase and so on. And you see here, in this case, a comparison between another instrument, the nanodrop, and the Photopette, and they both correlate very good. So those are some results of ethanol assays we did in different type of samples, also with very good correlation. I think I don't need to go into the details here. Another application which is performed many times in the life science labs are protein determinations, but not direct protein. In this case, a BCA method using a reagent, which is basically kappa 2 plus ion, and which forms a complex with a protein and then develops a color. Also here we say a very good linearity in the region for which this assay was built. And again, we have a comparison here between Photopette on the right side and another large conventional benchtop instrument here on the left side with very good correlation. So the Photopette system can be used in different industries. One of a big area for which we have developed many applications, and application notes are available on our website, are in the life sciences for DNA protein concentration, enzyme assays, protein assays like Bradford, cell counting, and also cell viability. For the industrial sector, we have developed applications for the galvano industry, nickel and copper, turbidity, and quality control protocols. In the environmental field, our Photopette turbidity is applicable, and we have different type of other water quality monitoring applications, for example, for wastewater management. In the food and beverage industry, you can find application notes for ethanol and lactate on our website. We have also developed protocols for the very fast measurement of starch, and we have protocols for the brewery industry, for example, for yeast, and we have an application note available for spirulina farming. To access our application notes, please, you can go to our website, and on the top bar of the website, you will find applications, or you can scan the QR code that you will see on this slide now. So let me show you some of the screenshots of our app for Android and iOS. I think what we see here are screenshots from the Android app. The app is available free of charge on the Play Store. And on the left here, this is a home screen, which you see first, where you see the battery level, not of your phone, but of the device. And you see the device which is connected. And one of the first things, if you use the devices, you will choose your measurement type. And then this screen here the second screen here will open, where you see, depending on the device that is connected, you will see the different wavelengths which are available, but you will also see the applications which are supported by this particular device. And by clicking on them, you can directly start measurements for these applications. So how will your measurements be represented? This is shown here. This is a table format where you see the wavelengths at which you have measured and the absorbance or transmission values of your sample. However, if you click on this graphical symbol, your table view changes to the graphical view, which is very handy and very convenient, in particular if you do kinetics. And on this graph here on the right, you see a kinetic where you see an increase of the absorbance values over time. And when you perform these measurements, you will see this in real time developing on your screen. The software is very easy and simple to use and does not need any specific qualification to use our device. So those are the features of the software. It allows now high quality spectrophotometric measurements for anybody. GPS, photo, notes, and date and time is embedded into the data file. The data file allows you to do a Google Maps overlay of your data, which is very handy if you do environmental testing. It has an inbuilt applications calibration function and what we call method maker. With the method maker, you can generate your own method within minutes. So it's multi-language support. It speaks English, German, and Chinese. It allows you quasi real-time sharing and export of your data via email or cloud. You can load your data into Excel or in other software to analyze your data. Also, the device has a self-test function and a backup and restore function, and it has a tutorial inbuilt into the software. So what you get as a customer from the Photopette technology, you get ultra-high portability. It's an ergonomic handheld device for spectrophotometric measurements of high quality, independent of a lab, measure everywhere on site. It's very convenient. It's wireless connected via Bluetooth, either to your tablet or smartphone. There's no need for sample transfer, and there is no cross-contamination when you are changing the cuvette tip. It allows real-time data recording and sharing, and everything is very fast, results in seconds. The quality and repeatability and dynamic range of the device is very good, and it's robust and splash-proof. It's flexible to use. It's affordable. It's priced as a fraction of a conventional UV-Vis spectrophotometer, and it's maintenance-free. There's no periodic calibration required to operate the device. It's smart. It's a Internet of Things ready device and seamlessly connected, through cloud storage. It's innovative. It has a new, workflow, and there's an opportunity for you to explore new applications. So what you get as a customer, you will get the complete kit of the Photopette, which is shown here in the left picture. And so please have a detailed look on our website about the different models we offer, including our Photopette Custom, where we are very unique as a company to offer to our customers to build virtually any device with up to 3 wavelengths from 260 to 1000 nanometer for specific applications of the customer. If you have product inquiries, please send them to Banksia Scientific Company with the email shown now here in this slide.
Thank you very much, Dr. Trau. That was a very interesting and in-depth summary of what the Photopette is capable of. It truly is a pretty revolutionary piece of technology. So I do thank you for your time to explaining it today. All of the links that you saw will be in the description below on the YouTube video, and we can give you more information. Just get in touch and we'll tell you more about how the Photopette can really speed up your workflow.
Okay, thank you,
Thanks,
John.
everyone. Thank you, Doc.
Okay, goodbye.
Bye now.